Alright, if you are new to my channel, kindly subscribe for more videos, and if you haven't subscribed yet, kindly subscribe for more videos as well. Okay, let's start. So differentiation. Our first video, we got to know that if I have a function f of x being equal to x to the power n as in a polynomial, then the differential, which is the f of x dx, or it can be dy dx, where in that case y is equal to f of x, okay, is equal to n x to the power n minus 1. Okay, so I hope you remember this formula. Okay, alright, so what if I have a function f of x, I have two functions like this multiplying g of x. Okay, what do I do about it? And I want to differentiate the whole of this in one. Okay, or if I have a function like f of x divided by g of x, and I want to differentiate this. Okay, how do I go about it? So in today's video, we'll talk about differentiating functions that are adding, okay, addition of function and subtraction of functions together. I just differentiate them, and we'll discuss the basic rules. Okay, alright, so let's start with addition and subtraction. So with the addition and subtraction, if I have two functions, let's say f of x plus g of x, okay, and let's say the whole of this is equal to y, then my dy dx, okay, is actually equal to df of x dx, meaning just differentiate f of x, okay, then dg of x dx, just like that. Okay, so if they are adding like this, what you do is just differentiate them term wise and add them. Okay, after differentiating them, each and every function, okay, so an example is if I have y is equal to, let's say, 2x squared plus x, okay, you see they are just separated by addition. Okay, so what I do is dy dx will be equal to, just applying our rule that 2 times the front of the 2 squared, that will be 2 times 2, which will be what, 4, then x squared minus 1, x to the power 2 minus 1, which is s to the power 1, okay, plus 1 times the one that is in front of x, and that is 1. Okay, so we don't write, then x to the power 1 minus 1, which is 0, so x to the power 0 is what, 1, so we get 1. Okay, so that will be h for addition. Okay, so let's look at the subtraction as well. Alright, we will need them, that is why we are treating these. Okay, so let's say I have function, let's say v of x minus u of x, okay, equals y, or y is equal to this. Okay, how do I differentiate this? Okay, so just the same like the addition, dy dx, okay, will be equal to just dv of x dx minus du of x dx. Okay, so let's look at an example. An example is, let's say y is equal to 3s cubed minus 4s squared. Okay, see there are two different functions here. Okay, so here my dy dx, simply differentiating this term, and that will give us what, 9s squared. Okay, I hope you are familiar with the differentiation now. Then minus 8x. I hope you are okay. Right, just using this definition. Alright, so that is it for the addition and subtraction, okay, the rule governing it. And let's go on and look at the product rule or the multiplication rule. Okay, alright, so with the product rule, let's say I have functions f of x, okay, or let me write the y first. Alright, so I have y is equal to f of x times g of x. Okay, then if I want to differentiate the whole of this, that's dy dx will be equal to what? First thing what you do is that you just maintain this side. Okay, so you write your g of x, everything that is there, you write it back, then you differentiate this side. Okay, and that will give me what, f prime of x. Let me write what we know already. Okay, so like you differentiate the first term and keep the last one, that will be what, d of f dx. of course we know the function of f. Okay, so plus, then you keep the last one, which is f of x, and differentiate. Sorry, you keep the first one this time and differentiate the last one. Okay, dg dx. So after that, you multiply whatever you get for this to g of s, and you multiply whatever you get for this to f of x, and you sum it. Okay, so that is the basic definition I can give you for the product rule. Okay, so let's take an example and go through it. So with this, let's say y is equal to, sometimes these are well, let me use another one. Okay, let me use another function. So let's say y is equal to s to the power 5 times, let's say, x plus 1. Okay, let me take this is the simplest example I can give. Okay, so with this, if you are to differentiate, we can multiply through by x to the power 5 and we will go. Okay, but let's use the product rule and see. The product rule is saying that first I keep the last one, which is x plus 1. Now I differentiate the first one this term, and that is what, 5 x to the power 4. Okay, then plus, I'll keep the first one, which is s to the power 5. Now differentiate the bracket. The brackets is just differentiating summation of polynomials. So okay, if I differentiate this, I will differentiate this one, which will give me 1. Okay, then plus, I'll differentiate this one, which will give me 0. So in effect, you will get 5x to the power 4, okay, into s plus 1 plus s to the power 5 times 1, which will be s to the power 5. Okay, so this will be our final answer. So if you want to continue this by simplifying, you can continue as well. Okay, so for now, this is what I will keep for keep for you. Okay, and this is what I'll have for you as well. Alright, so let's rewrite the definition again and we'll make use of it in the future. Okay, so we said that if you have y equals f of g times f of s times g of s, then dy dx is equal to, first, sometimes dy dx, okay, I'm just representing it, but it can be y prime, meaning the first derivative. Okay, we have other derivatives as well, so we'll talk about them in the future. Okay, alright, so dy dx equals f prime, meaning just differentiating f of x. Okay, f prime of x times doing nothing to g of s, so you just maintain your g of s, then plus your f of s again, then g prime of x, meaning df, this one means df ds, this one means dg dx. Okay, so that is it for the product rule. Okay, so keep this, you differentiate that, plus you keep the other one, that you differentiate the one that you kept first. Okay, alright, so let's move on to the quotient rule, and after that we'll take examples. Okay, so with the quotient rule, it talks about divisions. Okay, so if I have y is equal to v of x over, let's say, u of s, or let me use u of x. Okay, because most books use u of x over v of s. So u of x over v of x, then my dy dx will actually be equal to, first of all, you pick your denominator, which is v of x, then you multiply by the differential of the u of x. Okay, then minus, you pick your numerator u of x, then multiply by the differential of the denominator v of x, all over v of x all squared. Okay, now this is not a new formula. Okay, it's never a new formula. After treating the chain rule, okay, this rule, after treating this rule, you can use this rule to generate this. Okay, it's very simple, just that mathematicians just sat down and simplified it for the future generation like us. Okay, so that is it. So if you want to find the products, the quotient rule, that is differentiate two functions dividing, then this is a formula you use. Okay, and let's take an example and work on that. Okay, alright, so with this definition, let's say y is equal to s to the power 5 over, let's say, x plus 2. Okay, so with this we can't do anything to this, but just what try to differentiate. Okay, so it means my u of x is equal to what, x to the power 5, and my v of x is equal to what, x plus 2. Okay, now the first thing we should do here is that we should find the derivative for the top one. Okay, x to the power 5, and that will give us what, 5x to the power 4. Okay, then multiply by what, just x plus 2. Okay, and then we'll subtract it from, subtract the same u of x, which is for x to the power 5, then times the derivative of the denominator, which is 1. Okay, so if you're able to simplify this, then divide by what, this 1 squared. Okay, so it's very simple. Let me clean it and write the answer there. We said that this is equal to just differentiating the first top, okay, and that will give us 5 s to the power 4 into multiplying by the denominator, and that is x plus 2, minus this your numerator, which is s to the power 5, times the derivative of the denominator, which is 1. Okay, all over x plus 2 squared. Okay, now you can simplify this and go. Okay, if you continue to simplify it, we'll get the numerator to be what, 5x to the power 4 times that. So after simplifying this, then this will be your final answer. Okay, let's try to simplify it. If I multiply 5x to the power 4 through this, I'm raising it and writing it straight. Okay, but let me write it here. So I'll get something like 5x to the power 5, okay, at the top, plus 10x to the power 4 minus x to the power 5. Okay, all of this over, let me erase this. All of this over what, x plus 2 all squared. You can see that one of these will take one of these out. There are 5 of them, so if it takes it out, what will happen? Okay, we'll get 4x to the power 5 rather. Okay, so everything will be 4x to the power 5 plus 10x to the power 4 all over this. Okay, so this will be your final answer for the derivative of this. Okay, so that is a rule for differentiating functions that are dividing. Okay, alright, so let's move on to something bigger. Okay, so let's come to what we call the chain rule. Okay, so the chain rule is the most interesting aspect of differentiation. Okay, it's the most interesting aspect because it's the aspect that lets us differentiate trigonometric functions, logarithmic functions. So please kindly take note of this. Okay, pay attention and learn it for once. Okay, so the chain rule states that if I have, let's say, a function y, okay, is equal to, let's say, f of u of x. What does this mean? It means that f is a function of u, whilst the u inside this is also a function of x. So what do we do? Okay, how do you find your dy dx? So now our dy dx will actually be equal to df du, meaning you differentiate f, you write f again, f equals something, okay, something in terms of u, then differentiate this f in terms of u times differentiating u in terms of what, x. Okay, so you, after that, then you find your u, which is equal to some u of x. Okay, then differentiate this u of x with respect to what, x, then multiply it by that. I'm taking it again. I said if I have y being equal to f of u of it, meaning the f is a function of u and the u is also a function of what, x. Now if I want to find dy dx, then this is equal to df du times du dx. Okay, this means that du can cancel du and we'll get what, df dx, which is equal to dy dx. Okay, so this way I have y, which is y of u of x. Okay, then my dy dx is equal to dy du, okay, times du dx. Alright, so that is it for the definition. Now let's look at a typical example and we'll do some more other videos on that. Okay, Alright, so a typical example is this. Let's say y is equal to square root of x plus 1. Okay, now if you can see in the chain rule, what we do is that always you see one of the functions, or there's a function inside something. Always, that is how it looks like. Okay, so there's a function inside something. So if I let u be equal to, let's say, x plus 1, okay, if u is equal to x plus, then y is equal to what? The square root of u. Okay, of which the u is also what? Equal to this. This is what the definition means. Okay, so if I want to find my du, dy, dx, then I have to find what? Du dx first, which will be equal to what? Differentiating the whole of this, and that will give me what? 1. And my dy du is equal to, let me clean this part. Okay, so it's like there's a function inside another function. So what you do is you find your d, you represent your your sum of the function by something, so that you get y equals something u, just like that. Okay, so I have to say that but this is the same as u to the power what? Half from said. Okay, so it means that dy du is actually equal to half u to the power negative half, because half minus 1 will give me what? Negative half. Then my dy dx is actually equal to this one times this one, because I have 1 over 2 u to the power negative 1 over 2 times 1, and this will give me what? Half u is what? U is what? X plus what? 1. Okay, so it's x plus 1 negative half. Okay, let me clean some parts and write it clear. Okay, so this is what we had. Okay, so it means our dy dx is equal to this times this. Okay, so we get half u to the negative half times 1, which is equal to half u is what? X plus 1 to the negative half dot 1, and this will give us 1 over 2 square root of x plus 1 because of indices. Okay, so this will be a differential of this. Okay, so this is chain rule. Okay, so now let's look at something. Alright, so if I have something like this, let's take another example. Okay, so if I have y is equal to, let's say, x squared plus 2x all to the power 5. Okay, if we could see, then we can represent something in it, or we just try to represent something in this question by u. Okay, so if I let u be equal to x squared plus 2x, okay, then it means y will be equal to u to the power what? Y will be equal to u to the power 5. Okay, then my du dx should be equal to 2x plus 2. Okay, this is what we learned from our definitions. And then dy du is equal to 5u to the power 4. Okay, then it means that our dy dx is actually equal to what? Multiplying the two of them. Okay, and that will be dy du times du dx, which is equal to what? 5u to the power 4 into 2x plus 2. Okay, this will give us what? Let me bring the 2x plus 2 first, then 5. Let me first bring the 5. Okay, so first bring the 5 first. So this will be equal to 5 into this. Then u is what? X squared plus 2x all to the power what? 4. So this will be the solution to this question when you are differentiating. Okay, so that is it for chain rule. There are some special functions that before you can differentiate them, you need to know your chain rule. That is why we went through all these. Okay, so these are the basics for differentiation: the rules, how you got your first principle formula, how to differentiate a normal polynomial function. Okay, alright, let me list those functions that I'm talking about. That before you differentiate them, you need to know your chain rule. Okay, I'm coming to list them. So the special function that I talked about that they will always use chain rule is the log functions, the trig functions, okay, and the exponential functions. Okay, so with these three functions, in our next video we'll talk about how to differentiate them. And once again, I'm saying that know your chain rules very well, because that is what we are going to use. Okay, so thank you, and don't forget to subscribe to my channel if you haven't subscribed yet. See you next time.